Let's welcome our first speaker, Mr. Nimesh Shenoy, Director at Sigma Weld Electronics Devices Worldwide Private Limited. Mr. Nimesh Shenoy boasts a remarkable 20-year career in welding and induction heating marked by significant achievements. He has authored and represented over 100 technical papers at national and international conferences. His paper on aerospace welding earned a place in Welding in the World, a prestigious journal. Mr. Chinoy was honored with the Best Technical Paper Award at the National Welding Meet. He holds influential positions, serving as the Honorary Secretary of Association of Welding Product Manufacturers, a member of the BIS Electric Welding Equipment Sectional Committee, and ICM representative at the Indian Institute of Welding and a core committee member for welding in the Confederation of Indian Industries. His contributions have left an enduring impact on the welding industry. Mr. Chinoy today will speak on productivity enhancing tool and equipment for welding. So let's welcome Mr. Chinoy.
Productivity enhancement. And as we all know, India today is at a place where the order books for all is not a concern. The concern is delivering on time and at an appropriate cost. So the talk today is to increase your welding speed by 10x and finish your projects before time. If these are few things that worry you, that is worried about rising cost and timeline due to weld repairs, would you like to descale your welding process? And would you like to finish your projects before time and double your profits? This is something that interests you, then we'll probably be at the right place. Quickly, this is for production heads, factory managers, welding engineers, owners of stainless steel and exotic material fabricating companies who are into pressure vessel, limpets, dish ends, cryogenic vessels, aerospace components kind of welding, and anyone welding long seam or circular seam with GTAW process. So our focus today would be for TIG welding. What are we promising you today? At the end of this session, you should be able to bring down your welding time by about 90%, bring down your welding repairs by 99%, bring down your welding consumable cost by about 85%, and save more than 75% on your welding cost per meter. A little bit about me, I think Sashi has already shared. I have got more than 20 years of experience in application engineering, pardon me, in the field of welding and induction heating. I've authored more than 100 technical papers on welding, which have been published on various national and international conferences. Been awarded the best welding technical paper at the National Welding Meet. And our paper on aerospace welding was selected for the Welding World magazine. I'm also the Honorary Secretary of the Association of Welding Product Manufacturers of India. I represent the Bureau of Indian Standards, the Electric Welding Equipment Sectional Committee, ETD 21, and I'm the Industrial Corporate Member Representative for the Indian Institute of Welding, and I'm on the Core Committee of Welding for Confederation of Indian Industries, CII. Very quick about the journey of our company, Electronic Devices, established in 1974 and all the way up to 2023. We've been always innovating and adding new products from dielectric preheaters to induction heating equipments to induction cap sealers in India. We had a JV with an Italian company for induction heaters in 91. We today fully own that company and have an export surplus for about 80 countries. We established our full-fledged R&D department in the year 2000. And in 2007, we launched the first set of India's digital welding inverters under the brand name of Sigma Weld. And 2010, we extended our capacities of manufacturing from Mumbai to Umargaon, which is a part in Gujarat. And we professionalized our company in 2012 from a partnership to a private limited company. I'm happy to say that over the last couple of years, we got more than 6 patents. Our company has been awarded and recognized as the approved DSIR approved lab by the Government of India, that is Department of Science and Industrial Research. And we've won the National Technology Award this year. In short, 49 years of experience for electronic devices, 287 dedicated employees, 80 countries plus exports, and 10,000 plus happy customers globally. Few of the contributions: Chandrayaan 1-2 solid fuel boosters welding was done by Sigma Weld Equipments. The Gaganyaan semi-cryo engine heat treatment procedure is developed by us. The titanium bundles welding and end-pin pre-post-weld heat treatment used for all 6 nuclear submarines guarding Indian waters were done by us. More than 100 kilometers of welding aluminum foot-over bridges for defense. All the safes and lockers we use by Godrej, manufactured on Sigma Weld since 2007. Nuclear end-shield welding automation for the NPCIL, and critical repair joint for the first PFBR Bhavini project, which is the nuclear power plant. That project also we've done some major repair work for them. More importantly, 10,000 plus equipments working with over 1,000 MSMEs across India, helping build the nation. Few of the awards for the Make in India award for the product, the technical papers, the Pride of India award by the Governor of Maharashtra, Mr. Koshiyari, and the Minister of Technology, Jitendra Singh, awarding the National Technology Award this year. Let's come back to our topic for the day, that is looking at TIG welding and its advantages. We all know that it's one of the best processes. It's very clean, one of the best processes, one of the most good-looking beads that you can get, no spatters. You can weld in all positions, and it's possible to automate. However, we always talk about TIG welding being slow, lacking poor arc stiffness, also low depth of penetration, increased heat affected zone. You need a very skilled operator, and you have an amount of sub-end losses, that is the 10% of your consumable is thrown away because the operator cannot feed it in time. And therefore, the process is considered or deemed to be expensive. When you decide to do any kind of welding on a plate or a rolled shell, you have to make an edge preparation. That means you have to spend time creating the right bevel angle and the root face. If you do it manually using grinding, it's normally slow and inconsistent root faces. But if you do it with a machine, that is a beveling machine or a milling machine, you will always have consistency on the bevel angle and root face. By doing this, you will always be able to save time. So for example, if you're using manual grinding for a 8 mm thick stainless steel plate, you would require something around 10 minutes. But if you did it with a beveling equipment, you would do it in under 2 minutes. So the first thing, if you do it with an equipment, you always get consistency and you save a lot of time. Second, once the step is ready, you need to weld. Manual welding speeds are typically in the range of 60 to 200 millimeters a minute with a little bit of automation. The filler wire required to do this is close to about 350 grams per meter for an 8 mm thick plate. It's a small calculator. If you take out your phone and take a photo of this QR code, it will lead you to a form which will allow you to do a feed in the data, and it will calculate the weld deposit material required by you, and it will email it to you. Typically, if you look at it, if you want to do a 1 meter weld for an 8 mm thickness, you need to have 3 passes, root plus 3. That means total of 4 passes. So 1 meter results into 4 meters of welding. Total time needed is 67 minutes by manual and 20 minutes in automation. Setup time and interpass holding time, another 30 minutes each will be required because you cannot weld consecutively back to back. Otherwise, you have overheated material and it can bend or distort. If you move into semi-automatic GTAW, you can start feeding with a wire spool instead of using cut lengths of wire. It helps you have a single roll instead of multiple dimensions of filler wires. It avoids frequent start-stop of the filler wire. It avoids post-weld grinding of the overlaps. Most of the failures that you get, that is lack of fusion, lack of penetration, it happens at overlaps. So if you reduce overlaps, you reduce your chances of failure. You have stub-end losses. That means for every 1 meter cut length, you lose about 100 millimeters or 10 centimeters because the operator cannot reach the arc that far. And therefore, that's 10% of your cost of consumable throughout the project. And also, you need a helper to replace the filler wires or change in currents. Let's consider one project for you. If you were to make storage tank of 1.6 meter diameter and 10 meter length, as you see on the bottom figure, right? You would have 5 segments to weld of 2 meters length each and 1.6 meter diameters. This means you would have 6 circular seams to be welded with a total weld length of about 160 meters. And you would have 2 meters into 4 passes each, as we discussed before, for 5 seams. This gives you 40 meters of weld length on long seam. And for the circular seam, 1.6 meter dia, it would consume 1.6 into 3.15 into 4 passes each into 6 seams given 120 meters. So total length of about 160 meters. Manually welding, this would take close to about 44.6 hours to do. And if you do it with automation, it would take you about 13.33 hours. So this is the difference you will get. To add to it, filler material required is about 56 kgs. 10% of this, if you were doing manual, that's 5.6 kgs, would be out to waste. So you would have to buy more than 60 kgs to actually deposit 56 kgs. Number of machines to be added, you would have to decide, and number of skill powered, depending on the number of tanks you have to make. So you can assume if you are only able to produce one shell in 13 hours, something like this, plus you need to wait equal amount for the interpass. That means you need 26 hours of arcing time, which is close to about 4 to 5 shifts of welding time required per job. But this still takes a lot of time considering edge preparation, welding with cedar wire, and you are welding 60% without. So if you would like to do something that avoids all this together, that means avoids the edge preparation, avoids filler wires, helps you save 60% on gas consumption, and welds an extreme speeds of 400 millimeters a minute, yet have a very low heat input and very low distortion. Let's see what is the solution for that. We can do something called keyhole TIG welding. When you do keyhole TIG, the arc is constricted, you get more focused area, deeper penetration. The area is so focused, the arc, that you get 3 times the arc force required. Therefore, you have larger penetration and lower heat input. This is how it works. You need a torch. You need to have square butts on 2 plates. As they move forward, you will have a keyhole punctured right through. There will be a protection on the bottom with the purging gas that will hold the bottom together. And from the top, using surface tension, the molten pool will move further. Because you are not adding any filler wire, the base metal and the weldment has the same strength, tensile strength. So it's very good. A quick video to show you how this looks in real time. So this is the top version. You can see there is an 8 mm plate, no edge preparation done, right? A normal simple torch, as you can see, a water cooled torch, no clamping. I'll just fast forward this a bit for you. So you can see this is working at about 400 millimeters a minute. On the bottom, on the other side, you are seeing gas exit from the bottom. This is what is an efflux plasma, which shows you that the penetration is full and complete, and it releases all the gases from the bottom side. Once the welding is complete, you can see a full clear penetration joint, and this helps you avoid any kind of confusion at all. This can be used for long seams, circular seams, tube mills. You can weld stainless steel, duplex stainless steel, titanium, nickel alloys, stellite alloys, and to a certain extent carbon steel, all in single pass up to 10 and 12 millimeters. What you will need a Pro Series equipment from Sigma Weld with a SWAT mode on it. You need to choose the gas, argon-hydrogen mixture for stainless steel or alloy steel, argon-nitrogen mixture for duplex stainless steel or super duplex. Purging gas can be argon altogether. You can use a chiller unit to keep the torch cool if you're welding longer seams together. And if you're welding more than 8 mm thickness, we'll use a cold wire feeder to add a little bit of wire to take care of the undercut or underfill. These are speeds that we have tabulated. For Hesta alloy, they are about 550 millimeters a minute for a 6.5 millimeter thick plate. For stainless steel, we've done all the schedule 10, that is from 2.72 to 8 and 10 millimeters. And you can see the speeds gradually going up. So you at 8 millimeters, we are at about 400 millimeters a minute. And for Weldox, we are still doing it at about 400 millimeters a minute with 8 millimeter thickness. For the tube mill application, we were able to do for our client, increase the speeds for an 8.5 thick pipe, 12-inch dia, from 175 millimeters a minute to 300 millimeters a minute. And with this, you were able to avoid the filler wire altogether and yet get the RTR joints 100% of the times. These are few of the photos of the joints concluded. This is for a 5 to 6 mm thick pipe. You can see the weld bead penetration. This is the top bead. Flaring test passed, and here's a micro of the same section. If you were to do a long seam by normal manual welding process, TIG welding about 8 mm thick SS, it would take you close to about 102 minutes, considering 30 minutes for edge preparation, manual welding speed of 55 millimeters a minute, and root plus 3-4 passes to weld, about 72 minutes of weld time. Same thing if you were to do an automated process with an auto TIG, You would get root plus one pass. You could do it in two passes at 100 millimeters a minute. Edge preparation of 30 minutes. Welding time 20 minutes. Total project time 50 minutes. Same thing when you move on to do in SWOT. You can do it in a single pass at 300 to 400 millimeters a minute. No edge preparation time required. Welding time is hardly 3.5 minutes. Total time 5 minutes, including clamping or tacking. You reduce your time from 102 minutes to 5 minutes. Let's see what some of our customers have achieved by doing this. This is for a customer using stainless steel, manufacturing stainless steel long seams, plate to plate. And you can see the weld finish. This is achieved at about 400, 450 millimeters a minute. It's a 6 mm thick plate. All root, RT, other were passed as per section 9 of ASME code. This is a bead finish you can get. This is for a customer doing cryogenic vessels. They had a 6 and an 8 millimeter thick shell, single pass, no edge preparation, X-ray quality weld, including impact at -196. They were able to reduce their consumable wire consumption by 90%. And this entire shell was welded in under 4 minutes. That's a 1.6 meter long shell welded in under 4 minutes. Let's compare data for about 10 mm thick plate. Sorry. Using an existing TIG welding process, you would need 6 passes to do it. Using SWOT, you could do it in a single pass. Using filler metal, you would need about 1 kg. Here, you would need only 100 grams. Cleaning, you would need about 60 minutes. Here, you need 10 minutes per pass, so first pass. And weld edge preparation, you save 100% of the time. Shielding gas, you would save about 60%. Total cost per meter, you would save 70 to 75%. In addition to that, you would save 30 to 40% reduction in heat input, which helps you reduce the heat affected zone and distortion on the plate. Same example for titanium. One of our customers was able to produce 6 vessels well before time. They received their ROI well within the project itself. They welded more than 200 long seams within a span of a month. So you can assume titanium is very, very difficult to weld. And it takes a lot of precaution, but this is the results achieved by them. There's another client who achieved 6 millimeter thick Hesta alloy plate C276, 6 meter long in under 15 minutes. This is a plate before welding, after welding, and the root penetration. There is no distortion on the plate, thereby producing speeds of more than 420 millimeters a minute. This is one of the same plates that was welded, the actual fit up and welding procedure. This is being welded at the actual speed of 420 millimeters a minute. And you can see absolutely no problem. The customer has, in the last 3 years, welded more than 22 kilometers of weld length using this process. It's a variant of GTAW, so it's as per ASME section 9, it has undergone on the tests for root bend, phase bend, tensile, and it passes all of them, including impact at -196. Here are a few macros, 8 millimeter, 10 millimeters, and 15 millimeters thick, right? And you can see very clean, clear, exactly what you need. Let's conclude and look again at the project needs that we looked at the beginning of the project. That if you had to do the same thing using SWOT, your time required, the number of passes would be 1 instead of 4. So the weld length reduces from 160 meters to only 35 meters. To top that, your welding time speed is now at 2.5 minutes a meter. Therefore, your only arcing time required is 1.5 hours. Let's look at that number again. The arcing time required for manual welding was 44.6 hours. The arcing time required for automated welding was 13.33 hours. The arcing time required now is 1.5 hours. This is at least 30 times the speed that you could have improved. Filler metal required was about 0.35 kgs, that is 56 kgs in manual or automation. In SWOT, you would only need about 1.5 kgs to do this job. So you can imagine the kind of saving out there as well. You're looking at speeding up 30 times the process, reduction in consumable more than 90%, and 100% radiographic welds each time. So far we have seen that you can have 60% reduction in gas consumption, 83% reduction in number of passes, in cleaning time, 90% reduction in the filler wire consumption, 100% reduction in the weld edge preparation time, and overall 70 to 75% reduction in the total cost, considering factors like weld edge preparation, filler metal, labor costs, cleaning setup, welding, and gas costs. With this, you have two choices. Either you keep adding more machines and skilled manpower to encash the present order book at existing higher cost, or miss out on the opportunity to grow fast, or let us help you accelerate your TIG welding and capitalize on the low cost, high production, high quality welding growth. With this, should you choose to accelerate your growth, you can talk to us and we'll help you understand and take this forward.
Thank you, Mr. Chinoy, for the detailed talk on productivity enhancing tool and equipment for welding.